I'm working with SBDI support, at least part of my time, and I'm kind of having some kind of role of at least coordinating the work with our tools. Whilst Alejandro, who works at this consultancy, the Greensway AB, he has been doing most of the actual work with R and yeah, producing some of those tools. So today we are going to show you a few things you can do with R and using the SBDI data. And yeah, this is the outline. The welcome, we are already right there. I will start to give you an overview of the R tools. It's an analysis workflow, it's the Mirroreum, and it's a package to access data. The main part will be focused on actually demonstrating you the use of the SBDI 4R package to access the data and then to continue working with this data using other R packages to visualize and to analyze data. And we have focused this around two cases or examples. And Alejandro will walk through you this main part. And when we've gotten through that, I will finish off with a few words about training resources that we have and open up the discussion for how it's possible to contribute and what kind of future development you and we might see regarding those R tools. We then try to have just a short 5 minutes break to kind of reflect on what we've just heard and want to finish with a question and answer session. Yes, before we go ahead, Matthias already mentioned that we'll try to answer as many questions as we can in the end. So please, during the demonstrations, write your questions in the chat, and Matthias will try to take care of them. And those questions, they can be, for example, well, they're probably mainly being about the tools that we present today. But we invite you also to think about analysis tools that you would think should be developed, that you might need or would like to use. You could also think about other data sources that you would like to access through SBDI. Maybe you have ideas about workshops and courses that we could try to arrange. And there might be other questions related to our tools that you have. So you can post all of this in the chat. And yes, I don't know if all of you were there yesterday, but you have probably an idea what SBDI is, and that we have a web page with a portal to data and various numbers of tools. And here I just show you an image of the page where you can get an overview of or a list of the data sets that you can access through the SBDI infrastructure. And that's quite many different types of data. It's museum data, it's observations from national inventories, it's also citizen science data, so various things. And all of this you can access directly through the website portal. But you can also access it through R and directly, in the kind of analysis environment that probably most of you are familiar with. So here we start the overview of the R tools. We have one tool that's called the Mirroreum, which is an online R environment. It's basically an R Studio platform with some associated resources, and we will come back to that. We will talk about or demonstrate you the use of the SBDI 4R package, which is mainly, or the primary, the primary use of that is to actually access the data. And then we also have a tool, or let's say a resource, which is a workflow for analysis of biodiversity data. And it's a general workflow with advice. And I will start with showing you something about this workflow. Well, as researchers, we always start with some research questions. And in order to answer that, we need some data. So starting with a question, we can post a query and then access the data that we think we need for answering that question. Once we've got that data, we have a data set, but that's not really ready for analysis. We need to do quite a few things before we are ready to analyze it. We normally do some kind of data cleaning. We need to remove some outliers or obvious error data, or maybe there's some missing data we have to treat in some way. We also have to ask, well, is the data that we got now in our hands, is that fit for purpose? Is it really showing the amount of data or the type of detail that we need to answer this question that we start off with? And during that process of data cleaning and producing a data set that is actually ready for analysis, we often do things like data transformations, visualizations, aggregations, or need to filter the data. And that's a kind of, a back and forth, and we probably go through several steps there. And this workflow is meant to guide through these steps and provide you some background and some information and some linked resources that help you through this process. I put the link of that one together with some other links in the chat if you want now or later on to have a look at this. If you look at this workflow, then all of this you can do with various R packages. You can work in this mirror realm environment. And SBDI for R, just to put this in relation, is really this package is really concerned with mainly with posing the query, getting the data. And this is how the workflow looks like on the internet. It's basically a bit like a book, a web-based book with a number of chapters. There's an introduction. Then we have a chapter talking about the kind of data sources that you can get and also the importance of formulating questions. There was someone cutting the grass outside. Yes, chapter 2. And you can see that there's a number of links that bring you to some other pages where you can access things or get some more information. There's a chapter on data cleaning. We have a chapter, yes, and most of this includes also some examples where you can see there is also some code included that you can try out in R. After the data cleaning, we have a chapter on fitness for use, where we talk also about the bias that is normally there somewhere in the data that you need to think of and treat before you can analyze. There's a chapter on data exploration and transformation. And we finish off with a chapter on essential biodiversity variables, where we get more into the actually analysis part. So, and there's also some references. So this workflow is a very general workflow. It's thought as a helping guide to provide you some information, to find some resources. It gives you some examples, and we hope it's helping you to make decisions throughout this process. And it's also a dynamic resource, so it's very new, and you will probably find that there is a lot of information that you would like to have in there, which is not in there yet. We see it as a base to be built on. So we would like to fit your needs. And if you have the need for something that is not currently covered, then we'd like to invite you to suggest additions. And if you can, also contribute directly to it via GitHub. And I think Alejandro will say something about this later. What is the mirror realm? As I already told you, it's an online R environment where you can work with R directly on the web. The link is also in the chat, but in order to use it, you need to create an account. So this won't be possible right now, but later today you can send an email to SBDI and request an account, and then someone will fix that for you, so you can quite soon have a look yourself and test it out. All of these R tools, or the access to those, you'll find on the web page. If you go to the tools pages, there's a little box devoted to R tools and our APIs. And once you click to the mirror realm, you will get to this logging in page. And once you're in there, it basically looks like our studio, where you can directly work. So if you want to work with mirror realm, you don't need to locally install anything. And there's quite a lot of packages installed. I don't think you can add packages as a user, but we can do our best to add things upon request. So now we're coming to the SBDI for R package. As I told you already a few times now, it's a package to access the SBDI data. And it's a package that builds on another package, which is called the ALA for R. And ALA stands for the Atlas of Living Australia, which is an open source code development, which provides a similar portal as the SBDI portal, because SBDI is part of this Living Atlas community. So we are building on that development. And so the SBDI package is basically some kind of wrapper that builds on the ALA for R package. And here's a little caveat. We have built this SBDI for R package on the ALA for R package, but this package will be replaced with a new package that is already running, I think. It's called Gala. So we will have to do some work to actually adopt to this new package. But for the moment and for a little while in the future, it will be possible to use everything right now, because the ALA for R package is still available. So we will, in a little while, demonstrate you this using two examples. One is using data from a national survey, and the other one will be using opportunistic citizen science occurrence records. And yes, all of this, what we present today, you can try it out yourself. There's a tutorial, the R tools tutorial. The link is also in the chat, where you basically can walk through those examples yourself. So this tutorial covers like using SBDI for R to access data, how to integrate it with other R functionality and packages, and yeah, shows you some examples of how you can work with the data. And I just want to briefly mention that there's also some documentation about the SBDI for R package. And there we have a page, it's called the Introduction to SBDI for R. The link is also in the chat, where you'll find some more code, some more details on the use of this package, and also some more examples. And this was my overview. So now I would like to hand over to Alejandro.
Yeah, thank you, Deborah. I will now share my screen. Did you see? Which screen are you? Yeah. So just a few comments on the SBDI for R package. As we speak, or during these weeks, the ALA4R package has been retired from CRAN, which is the common repository of packages, which is curated. So, and when you install following instructions SBDI4R, it assumes that it can download the ALA4R package from CRAN. So we will shortly add a comment how to install also the ALA4R from another repository. But that should be no major problem. As Deborah mentioned, I will show you very briefly the capabilities of the SBDI4R package with two examples, one from a monitoring dataset and one from an opportunistic dataset. And show briefly the commands. The idea is not to go through every code, but just to show what is possible to do with the package, and then you can follow the tutorial yourself. The first example, as mentioned, is based on the Swedish electrofishing registry from the SLU Aqua database. It has about 2.8 million observations starting in the 1950s. The first capability of the package then is to start browsing the data, what is available. And for this, we have developed this particular function that is not in the ALA4R or in the Gala yet, but maybe we'll move to that package as well. And for that, I will show you how you can create your filter. So the aim is to create a string text variable that stores pieces of the filters that you want to apply to your query. And you can store those in a variable. So this is my my mirror environment, and I call the library SBDI4R. And the first thing that I do is call the pick filter function without any arguments. I can write directly the type of filter that I want to introduce, but if you don't specify anything, it will ask you, do you want to browse by resource, by species list, or by layers? And there is more documentation on what each will show you, but roughly the resource is the kind of data you want. The species list is if you want to filter by a defined list of species that could be conservation interest species and so on. Or if you want to filter and to browse which kind of environmental layers or additional layers you have in SBDI, which is plenty of. We type resource, and then we get a next question. This is an interactive way of listing all the resources that we have. We first are presented with a list of institutions, and we can try, for this example, we want to start with institution 3. So we see that if we go through the list, the Swedish University of Agricultural Sciences is the institution number 3. We hit enter and we get another question, which is, do you want collections or data resources? There is a difference in how this data is presented, but for this, in this example, we know that we want the data resource 10, which is the Swedish electrofishing registry. So we type DR10, and that's it. We now have added a filter in our variable. We can continue if we want to add more filters, which will be added as AND statements in our query. Sorry, as OR statements. So it's keeps adding different sources. Or we can just hit enter, and we are presented with this string that is going to be passed as a part of the query. So we want to limit the search to only this data source. Let's try to go back to the presentation. Yeah, so then the variable filter query string will have as mentioned, a vector of different strings. We can add to that other parameters, like for example, if we want to filter by year, we concatenate the previous filter string with a particular syntaxes for how we add beginning and ending years in the range. There is lots of documentation on how you can specify this string on the SBDI APIs documentation that is in this link. But this is just for you to know that you can add in this vector multiple different kind of filters. And the next step is to search for the occurrences. So the function occurrence will retrieve the occurrences that matches your query. You should when you install and you go through the tutorial, you have to carefully read the first part where you are introduced to the SBDI configuration, the function, where you have to add a valid email and a download reason for your query. And you can search also. There are different download reasons, and there is documentation of that as well. Yeah, so you get a complete string. You just pass the filter query equal to your filter query string, and the data is downloaded into these other variables, XF. XF will come also with metadata, not only the occurrences. Therefore, when working with it, you have to specify that you want from this data that you downloaded, you have to specify the data. But just for you to know, you also have metadata that comes with the observations. And just straight from the package, you can directly produce some summaries with the function occurrence plot, which generates by default PDFs, where you have 1 page per species, and you can specify that how you see the observation locations, and if you want them to highlight different types of assertions, what kind of potential problems each data point has. So you have a first look on how the data looks like. And now I've been browsing in the wrong file. Yeah. But there are many options on how you can plot this data. The occurrence data will come with columns for the coordinates, which as standard comes in the coordinate system WGS84, which is standard. And for example, you can use the package leaflets to produce an interactive map and browse these data more interactive and follow a particular location and see how many points you have for this particular area. Yeah, and the possibilities are not endless, but very wide. You can produce many different types of maps and plots. You can also explore quickly make a temporal summary by just quickly making a histogram of the column year, for example, and see whether your data is biased through time, or if there is a decreasing, like in this example, a decreasing trend in the number of observations, how many records we have for each year. And this is just straight with the data as we download it. We can look also at the different species, if we have any particular species that is more represented than others. And you can do these by the common name or by the scientific name, and quickly produce a table with the frequencies of observation, the number of records for each species. Here I am just presenting this 6 first, but it's a long list of species. And you can, of course, download that as a CSV to share with other colleagues that don't have access to R or don't know how to. Yeah, a little bit more advanced analysis could be a spatial biodiversity analysis, where you look both at space and different taxa. And the SBDI for our package provides you with both polygons for standard polygons for Sweden, the territory, the municipalities, and so on, and with standard grids. It's a 5, 10, and 50 kilometers grids over Sweden, which are the same that are used on the web portal, in case you want to match that. And here we show quickly in the tutorial how you can overlap your observations to that grid set, so you can do summaries by using that grid. This package uses it has now migrated to SF, which is a package in our, which is the most common package for spatial analysis. So make sure that you install the latest version from GitHub that is migrated to SF in order to be able to follow these examples. Otherwise, you will get warnings on mismatch of data, because the previous version of the package had all the data in another format. Yeah, so you can overlap and make an intersect of the grids and the observations, transforming the observations as a spatial layer, and from these, you can also plot. The result of this intersection will be a list. If you're familiar with R, the data could be stored in different formats, and list is one of those where each element has another data set or vector, or could have different formats of data within each element. In this case, each element of the list will be a data frame with the full set of observations, and you can apply some statistics to each of those grid sets quite easily with the function apply, list apply. And you can restrict that to only those grid cells that are not empty. That's why in previous, the last thing that we do is the which not empty to make it more efficient, and only work with those elements in the grid set. And finally, you can plot over Sweden this grid set with a standard color gradient. I keep browsing wrong. Yeah, so it's pretty easy to come to a result like this, where we show both the Swedish borders and the grid set. We can now ask, what is the richness, for example, across latitudinal gradient? And using here, we wanted to show how you can use, for example, the tidyverse syntaxes, which has been now adopted in the more or less in the new release of R, which uses these pipes mainly to show more easily what steps are you doing. And here we show that you can round the coordinates to make groups. Then you group by those coordinates and select species, and do some filters and calculations to reorganize data so that you can have a figure where you plot the latitude versus how many species you have on each of those categories of latitude. This is now disregarding the grid, working again with the raw data. And again, another way of we try in the tutorial to use different syntaxes for making plots and maps, because there are different different ways of doing everything. Some people like working with the library ggplot2, which is pretty standard for figures. Some other people like the base functions. So we try to mix those so that you know that it's not linked to any of those syntaxes. So that was with the monitoring dataset. You can pretty easily transform these observations into different formats to produce summaries very quickly. On the next example, we will go a little bit farther on how you can transform this data and start cleaning and grouping the observations in another way. And for this, we will explore the opportunistic data on dragonflies. Again, we start with the name searching. The SBDI for our package has a set of functions to make taxonomic searches. For example, you can search by full text or Odonata. Give me everything that is available that matches the word Odonata, which is the order for dragonflies. And in this case, we're interested in those observations from the Swedish Citizen Science observation portal, which is our portal. A quick search will, so yeah, when we run a function, we will get the URL that we're using to get that query. So if we use this URL in a browser, we will get the same results, just for you to check. Sometimes you want to debug some of your code. And in this case, we're making a query for Odonata, and we're filtering by taxon. And what we get is, we see that there are many things that match the word Odonata. Some of them, I guess, are viruses, because they are called virus. There are no occurrences for those, but if we anyway want to remove those from our search, we want to restrict the search to something that is more appropriate for the order Odonata. So we can see, we can use the function SBDI fields to see which is the filter query string, the keyword that will filter for a specific order in this case. So I can show you in RStudio as well, how do we work with these search fields. So let's make this one bigger. If we write, I can clean this so we start fresh. So if we use this function SBDI fields and write, for example, general to start browsing from the first level, there is an error. Of course, that's what happens in live when one tries to show something in live. That should be specified. Okay, if I restart maybe my session. Yeah. So we're presented with a list of names for these search keywords that we can use in our query. We have used, for example, data resource in the previous search using the big filter, but we know that we can use all of these ones, and you even know if it is indexed. The indexation is a process that something that is done in the database to make searches faster, and you know that, yeah, you're presented with which of these filters are indexed, and what's the data type that you are expecting from the search. And we see that most of the or many keywords have the _s at the end, because in a general search, yeah, you use this search keyword. That's not very explanatory, but you have to use these keywords, and we will see how what else do you use. So we make a search with order S, colon Odonata, because we knew that that was how we wanted to look for, and we restrict the search to a page size of 10, so we can just skim what is coming out from list. And what is coming out is list with with taxons that are ranked species, so are defined by at the species level, and these first taxons have no occurrences, although they are registered. But at the bottom of this list, we will surely find some other taxa that has some more observations. And all of these are only species within the order Odonata. Now we can download the whole taxonomic data for this order Odonata, and that we do with tax info download, the function that will download the whole taxonomic tree for Odonata, everything that is within Odonata, including subspecies or definitions lower than species, and genus and orders and so on. And we can save that for later use if we want to make a specific search. But we can, for example, restrict after we download the data. We can restrict the species to anything that is on the rank is equal to species, and the genus is not empty. And in that way, we filter out everything that is, for example, hybrid species or any other sub taxa that we don't want, and also, for example, the taxa that matches only the genus. We can also apply some filters. In this case, I won't show it, but in the same way, we make a filter for the data resource DR5, which is art tolerance data from the institution SLU. And we apply also a time restriction to search only within a period. And we also want to apply to search a spatial filter. So in this case, we want to send a string that contains a polygon or a geometry within which the database will constrain the search. And for this, we have to do a couple of steps. These strings comes, we have to send it in a particular format, which is the well-known text. It's a format in which one of the formats in which geometries can be passed. And we can do that using, for example, one of the layers that comes with the SBDI package. So we get the data set suite from the package SBDI, and in that data set we have, again, it's a list with many layers. One of those layers or elements is the counties, and we want to select from this list, from the layer counties, the column name for and we want to match all these counties that we know are what define Jättaland, which is a no official region. We just want to gather these counties. So we get an index for those, and we just pick those and save those as Götaland. And now we have to construct a WKT string, and it's pretty easy. We just transform that that polygon into a particular coordinate reference systems, which is this number matches WGS84, which is the standard that has to be passed. In this case, the data is already in WGS84, but we show this in case you have another data that you want to transform as well into. You don't have to forget this step to transform the data, otherwise the search will return nothing. And then we don't want to pass many polygons within the WKT, because the string cannot be too long. We have to constrain the number of characters. So we make a union of all the polygons, and then to make it even shorter, we make a convex hull around that simplifies the function without leaving anything outside. And then this is a very important step, not to forget, the APIs. Right now, I mean, I don't know if that will change or not, but right now it only takes, even if you send one polygon, it takes the WKTs in a format that is a multi-polygon. So you have to cast or transform that polygon into what is called a multi-polygon. There are lots of detail here. You can investigate more what is a polygon, what is a multi-polygon, but don't forget to make this particular step. And then quite easy, SD as text, and that will give you a string. That is what you will have to add to the filter query. Just to summarize, this is the string. The text that will be passed is too long to in the screen, but you have a series of coordinates describing each node in the polygon, and we have the counties, the other united or dissolved polygon that is the outer shell of Götaland, and then the search polygon, which is the convex hull, to make it even a shorter string to pass to the URL. And again, we download the observations, the occurrences from data. So we specify taxon, order Ordonata, and now pay attention that we write order, not order S. The order S was when we did a general search. In this case, we are downloading occurrences, so we have to check for the keywords for occurrences, and that can we also show you in RStudio how it looks like. With the same SBDI fields, instead of general, we look for occurrence, and then you will get the keywords, which are many more, to filter the occurrences. As you see, the list is much longer, and if you look in this one, the order, the keyword that matches order will not have these _s. These details are need to be remember when you write these filters, these keywords by yourself. Yeah, then you add the filter query, which adds the times and the spatial, the time, but the spatial filter has a particular place, which is the WKT argument in the function occurrence. And then you have extra, if you want to add extra columns. All this is documented in the package documentation, but just wanted to show how the capabilities of these functions. So you can add columns to the standard set of columns that comes with the data. Yeah, so then you get again a set of observations, occurrences. We go further in this example and use the package birds to summarize sampling effort and check whether the data is fit for use. We use a grid over 25 kilometers to do this summary in this example. Also, the birds package was on CRAN, but not any longer. Some changes are being done. Make sure you install it from GitHub. There is documentation there, and you can also find in GitHub the documentation on other functions in the package. But the basics of these other packages that you organize data, saying which are whatever data format you get data from, you say which column is defining the rank, and you want a specific rank to be preserved, not the other ones. You want to filter out all the other ones. You define which columns are defining your visits. So we will collect all the occurrences by collector and by locality to create visits, groups of occurrences that most likely match same event of observation. And this can be defined in many different ways, even using the grid instead of the defined locality. Then you define which columns of this data set will define you the time, and in this case, you either use a complete date column or the year, month, and day, and then they will merge them, and which one are the coordinate columns. This will then will produce will organize and produce a condensed data set, which you can intersect with the data. In this case, we will produce also a grid set. We will get from the SBDI for our package the 25 kilometer resolution grid set, and we will intersect with Gotland, Jätteland. So that is the other polygon that we created. So we will only want those grid cells that matches, that overlap the Jätteland polygon. And we will use only those grid cells to summarize the data. So OB is the organized data, and we will summarize that. And the summarized data set will have different elements where you have spatial, temporal, and grid cell-wise summaries of the data. You can explore more on what that means, but basically, with a quickly exploring the spatial temporal summary, you can plot over this grid cell quickly how does data vary over time and space, summarized by, for example, number of observations, which is one of the variables that comes with the summary in this package. So in a few lines of code, you can get these plots showing time series, how this opportunistic data varies. You can also make other kind of plots directly querying this spatial layer, in this case using again ggplots, but you can explore the number of visits using the column that comes in the summaries, the number of visits or the number of species, and you can contrast directly what's the distribution of the number of visits, most likely increasing in nearby cities like Malmö or Lund. Here maybe it's the university having a high impact, but the number of species has another distribution. Again, this is not corrected data, so that doesn't mean that the number of species is lower in this other area, but at least we have a first visual representation of where the data has been collected. You can also explore quickly the temporal dimension, for which you will have a daily base summary on the. So if you query from the SB element that you created, the temporal element, you will get in the data set that is format XTS, is a particular format for data time series, and you will have the number of observations, number of visits, and number of species per day, and you can quickly query a particular range or month, and you can use the package XTS to make some quickly plots also on the temporal variation on the number of observations and number of visits over time within the whole data set. Then you can explore quickly these some species summaries. If you run the function species summary on the SV, you will have summarize number of cells, observations, and visits for each species that has been observed in this data set. And using again the library dplyr, you can make some transformations and some other calculations on focal species. For example, we want to focus on these two species and create some summaries for only these two species, and look in this case at the number of visits where the species is reported relative to the total number of visits. And this is just the code to show you that in a few lines we can produce what is a standardized set of presenting the relative number of visits with observations for each species. This is again not correcting for missing observations or big biases in the observations, but at least we know if there is any trend among the total number of observations, the proportion of these two species within the whole set. And that was it with the two examples. You can browse more in detail and follow the code yourself. But as Deborah mentioned, your collaboration is appreciated, and there are many ways in which you can contribute to these functions. One would be, of course, sending your request via the support center, as Matthias showed. but also submitting either issues on the GitHub repositories with your ideas or presenting the bugs that you have encountered. You will certainly find some bugs. Or you can contribute also by forking the code, so making your own copy, transforming, adding functions as you please, and then submitting a pull request in which, if everything works, could be merged into the original repository. And the repositories that you can contribute with are the actual Miriam, in case you want to add some package or you see something that could be improved. The actual SBDI for our package, again, this is not going to be developed further as is, but has to be adapted to the Gala package that is already in CRAN. But anyway, if you have an idea for a cool function that you want to use to summarize in a particular way that you think is going to be useful for other people, you can add it and submit your pull request to that package anyway. And those in charge of adapting can take that with them into the next version. The general analysis workflow, which is a web page, is a book down page, but you can also correct some typos if you want, or adding sources of information to that. And this whole R tools tutorial, you can also contribute by making changes into that tutorial. Just a short comment on this tutorial. The presentation that you saw, it has been migrated to SF, to this spatial format, but the tutorial is not yet adapted, so you may find some differences, and we will shortly bring those changes into the tutorial. And with that, I leave the floor again to Deborah. Thank you.
Thank you, Alejandro.
I see the question in the chat right away. It is a bit technical, but the XDS is particular for time series. You can easily convert to other formats like lubridates or daytimes. But the XDS, we saw that as best alternative to working with time series, where you can quickly aggregate or fill in gaps and so on.
Okay, if you stop sharing, then I can get back to mine. Yes. So as always in real life, it looks kind of nice if someone presents it, but you basically have to try it out yourself. Following the tutorial with the code provided, it's not really that difficult, but as also Alejandro kind of said, you probably at some point encounter some bugs, and then yes, you can easily contact us and we try to sort it out. If you want to try it out directly using the Mirror Realm, you have to first apply for an account, which is not a difficult thing to do. Someone has to take care of this. And then once you can log in, the packages are installed there. You can, of course, also install the SBDI for package, and you have to install the other package separately. You can, of course, install that locally as well. Yeah, and the main part of what Alejandro has been showing you today is in this RTools tutorial. And yes, so please try it out. A few words about training resources. The first ones we have already talked about. This is specifically to these RTools that we presented to you. You can also on our help pages find some more documentation or links to training resources that are maybe more general. There might be other R-based courses or training resources that you can access. This is also, there's a few things there, and those will extend in the future. So here's a start, and we will develop this. And this development will be partly through you, because you will have some more information or some more resources that you want to use or need to use for whatever you want to do in your research. You might want some more data sources. You might want some more analysis tools. You might be interested in specific workshops, some or more specific, some courses. You may have some other ideas. So please, I say this again, that your ideas and your input are really welcome. And that more or less brings us to the question and answer session. As I mentioned already in the beginning, please, if you have some questions about the tools that we presented you today, write them in the chat, and we will try to answer them. And also, if you have already now ideas about analysis tools that you would feel are useful for not only you, but also some other people, write that in the chat, and we can discuss those. Also, if you have ideas about, for example, data sources, workshops, and so on. So I now suggest we just have a 5-minute break in order to recover from the information flow. And let's see what the time is. Well, let's say we have an 8-minute break, and we are back here at 11:20. Okay, so we are back. It's 11:20 now. Do you, Matthias, want to resume your moderator function?
Yes. The moderator function, I'm trying to find it on Zoom now. Where it is. Okay. So welcome everybody back after 5 minutes break. We have a few questions. I think we start with those. For example, Jens Åström from Nina asked, do you plan to keep up with the development in the Australian original package so that SBDI for R stays an updated Swedish version of Gala with perhaps some extra functions? Or could SBDI for R break off from the mother packages? What is the design philosophy?
Yes, and I can start answering that. Well, we have been thinking of moving towards using the adapting to the new ALA package, this Gala package. This Gala package is already out there. It's already on run. It basically contains very similar functionality as the former ALA 4R package, but it's designed in a little bit different way, and it's a bit more efficient. So we think it would be best for us if we can move and adapt to that package instead. Of course, in practice, one could also break off, but that would require even some more development, which I don't think we will do on our own. So we basically we think of adopting to the Gala package, so to keep our functionality
Another
running.
possibility, sorry to interrupt, is that Gala modifies its package to allow other platforms to use the Gala directly. And I guess it's being worked already in that direction. The problem with that is that then SBDI will be dependent on the time frame and the schedule of the Gala development.
Yes, thank you.
Well, if I may rephrase that question, then is there any advantage you see in breaking out and creating your own kind of package development? What would be the advantage with that?
Alejandro?
That would be mainly independence in coding, but that would require double effort.
Yes. Okay, I hope this answered your question, Jens, but I think we have enough space to open up for direct questions. So Jens, if you want to come in and continue asking on that matter, you're welcome to open the microphone and ask. Otherwise, I hope we answered your question. Okay. All right, but then we can go. I have a question. So Miriam, why would I use Miriam? I'm very comfortable with my own RStudio on my laptop, and so what's the advantage of using Miriam?
Well, my short answer would be if you are very comfortable with what you have installed on your laptop, then you go on with that. But if you want to have an easy solution without installing everything yourself, then you can use Miriam. But perhaps Alejandro wants to add to that too.
If you want to work with your iPad that doesn't have the same computing potential or capabilities than a full-fledged computer, then you can use Miriam server that it can run directly through the database and will, it will have
So
computing power.
Yes, it's computer power. It is backed up by a good server, so if it's computation intense, then Miriam will be faster. Is that right?
Yeah, that's right.
And I will already have many of the packages installed. I won't have to install them myself. That's another advantage.
It keeps a constant image of the packages. It won't update as soon as there is an update. So in case there is it could be that some packages become there is a conflict of versions and something that used to run won't run any longer if you keep updating all the packages all the time. So this keeps an image of the things that work.
Yes. Okay. And have you used it for teaching or anything? Is there an advantage using it if you want to have a workshop, let's say, with 5 people, and you want to run basically what you have done now? If we want to do this more practical and everyone should do it on themselves on the code, wouldn't that be a good thing also to do it through Miriam? Because everyone has exactly the same version of the same package and R and these things. So I think there may be another advantage there as well.
Indeed.
Okay, now we have a comment from Frederick Ronquist, the acting director of SBDI. He thinks it's important to have this discussion that whatever strategy we choose, that it's based on on what we all think as developers in Sweden. So yeah, I can also only encourage you to share your thoughts with us. And if there are strong networks, but now the question is that this question that actually came from Nina from Jens, so it's Norway. The community doesn't have to be a Swedish community, it could be a Nordic community that makes a decision at what functions we would like to develop and how we're going to do it. Now is another question from Frederick. How many current users do you think Mirrorium could reasonably support during a workshop?
I wouldn't be able to answer that question. Maybe Manage or Marcus that are more involved into the server.
I guess we have to put it to the test then, starting with 20 or 30. I think 20 or 30 is a reasonable number, and we already have a few of these workshops scheduled for the end of the year, and then we will know. I would expect it can take 20, but then if you scale up from there, it may get. Yes, there are concrete plans for our workshops. The dates haven't been finalized, but we had our workshops running in the past as very short hands-on exercises on different levels, both for first-time users of R, so you go through the basics, but then also more advanced users of R, where everyone is assumed to know R and has it installed, and then you go into specific packages and functions. So all of these are scheduled, but they are not announced yet because we're still working on the dates. But I expect they will come at the turn of the year, beginning of next year. Yes. Okay, Manaj has answered. So we haven't done a lot of stress testing. That will be probably. We will be busy with that in the next weeks and months to stress test the Mirrorium. If you are new to R, where do you start? Well, we have some very basic R tutorials and these e-learning modules online on the website. You can find them on the website. So if you think it is difficult to get into R, you can contact us. We have also regular courses, at least at the Gothenburg Global Biodiversity Center, where we introduce students to R and the R environment. And we have a few of these packages where it's really getting started, downloading packages, making some very easy graphs, and getting comfortable with the whole environment. So I have another question. Now, I heard that yesterday already. Alejandro, you showed Swedish data, but now ecosystems, they go across the border. So if I have data from an ecosystem, let's say a forest ecosystem that goes across the borders of, let's say, Sweden and Finland or Sweden and Norway. So how does that work? I want to analyze this data with SBDI for R.
Yeah, but that depends on the data stored. I'm not so much aware of how much data, how comprehensive data the database is across borders. If you go through maybe GBIF package, so the GBIF database, maybe you get most of these data sources and even other data sources across the borders. But as long as you download the data, so the SBDI for R package connects directly to SBDI data sources. There are many of them. There are different institutions, as you saw. but it's whatever is in Swedish biodiversity infrastructure. If you want to go across borders, maybe you have to go to another broader infrastructure, which may mean that you don't get the last version of data sets. Maybe there is a delay in updating those all the bigger data sets. So that depends on what you look for, how you search. You can always, once you have downloaded data, then you can plot and see the fit for use in your particular question.
Okay, that was very good to know.
Yes, yeah. So Alejandro was correct. It depends very much on the data sources, and there's a number of different data sources, and some of them, for example, the museum data sets that are very often actually covering a larger region than Sweden, whilst the national inventories, well, by nature, they are covering inventory data that has been collected in Sweden.
Yes. So, yeah, I just came across this question because it's the most, in my experience, the most typical case is not when somebody wants to analyze data from a country or like public data. It's often a merger of, I have my own data, but now I want to enrich it with data from public resources, and then they would go to SBDI to find Swedish data, and maybe even to Norway to find data from if they're relevant from another country, and then download it, and then they process it in the way you have shown it using SBDI for R. So I think that's the way how it can be done practically.
Yeah, that would be quite easily possible, I would say, especially when working with R. You access this other data from somewhere else, and then you access the Swedish data, and then you easily merge it, combine it.
Good. Here we have another question. Can you use ALA for R, GALA, or SBDI for R to analyze data from other living atlases instances? For instance, the French and the Spanish instances.
Well, as we mentioned, one of the ways the GALA could be developed is that they allow the configuring it to link to different instances. Then you won't need to have specific packages for specific instances. But right now, as they each link to particular instance. They point to specific APIs for each country development. Yeah, so if there is no package for the French or the Spanish yet, then you will have to use their APIs directly if they have, and that would be much more it will require much more knowledge in R to use the APIs directly. But if you know the APIs, you have access to them, you can use through R without any package.
Thank you very much. Next question to you, Alejandro. What do you think are the functions you'd like to see being developed in the next, let's say, in the next year or two? Anything that you think is missing in the way you can explore the current data resources right now?
Well, there are, from the beginning, there were intentions to make more summarizing functions, more exploratory functions to mimic what was available in the analysis portal from Temporal, for example, or other portals. Those have not been so much developed yet. There are, possibilities to develop some plotting functions, some quickly scatter plots or whatever other visual summaries that are very useful for initially exploring data. Of course, the goal of this package is just to extract data and filter, to download a filtered data set. So I don't think the aim is to have so many more summarizing functions, but exploratory functions that help you to know if you can filter a bit more directly from the database. You can always filter afterwards, but these packages to interact with the database.
Thanks. Thanks so much. Is that the same way you see it, Deborah, or have you any important function that is right now missing that would be really useful to have in the SBDI for R?
No, I don't have so much to add to what Alejandro already said. Yes.
Good. These are all the questions that I had collected. Is there anyone else among the participants who would like to ask and discuss any more particular questions?
Just a short comment. In the tutorial, we explore a bit more on the live, not in the presentation, but in the other tutorial, we explore a little bit more on how can you make use of more of these resources that are available in the SBDI, which are many more, like other layers that are being indexed. So you can directly in your search bring like summaries for climate variables or other things in together with your data, or limit, for example, your search by certain climate variable, something like that. And to just John, keep in mind that you can explore many more variables in the SBDI, which is very complete. That's the
Thanks so much, Alejandro. Okay, then I think there's no more questions. So, Deborah, is there anything? Should we wrap it up here, or?
I would say we wrap it up here. Yes.
Yeah, then I thank everybody for their attendance. I think especially I'm thanking Deborah and Alejandro for the very nice presentations and demos. So that was very wonderful to listen to. And yes, then I hope I see many of you on Wednesday and Thursday, 10 o'clock under the same link. So thank you, everybody.
Thank you.
Thank you,
Bye-bye.
Matthias. Bye-bye.